While monitoring the population of koalas in a sample region, the following variables were recorded. M stands for male and F stands for female. A. Is this data nominal or ordinal? B. Construct a frequency table and include percent frequency. C. What percentage were female? And D. Interpret and write a summary describing the frequency table. Okay, the first thing we want to do is go ahead and set up a table with 3 columns. First column we have the variable. So in this case the variable we're looking at is female or male koalas. So then we go ahead and list the variables, male and female, in that first column. The second and third columns are the frequency. So the first one here is the number of males and females, and then we're going to go ahead and convert them to percentages using the total value. So firstly, let's look at this data here and let's count up the males. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we can go ahead and put 12 in that column. Then we do the same for the females. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's put 10 there. Now just to make sure you didn't miss any, count the total. You should get 22. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Now to work out the frequency for these two values, so we'll do the male first. So it's this number here, the number of males, divided by the total number of koalas in the region, 22, times 100 to turn it into a percentage. So doing that out on the calculator, you will get 54.6 to 1 decimal place. And then again for the females, in this case there's 10 females on a total of 22 koalas, times 100 to turn it into a percentage. So that will give us on the calculator 45.4. And then to finalise the frequency table, these need to add up to give 100. Now if they add up to give 99.99 or 100.1, it means that it's just a round off error because of the way these have been rounded off. But at the end of the day, if you don't round off at all, you should get 100. So just put 100 in that position. So that's actually the answer to part B, construct a frequency table and include percent frequency. So this is the percent frequency. Now I missed part A, let's go back to that. So is the data nominal or ordinal? This is the data, the variable here that they're talking about, male, female. Is it nominal or ordinal? Now you can categorize the data in terms of male or female, but you can't order it in any way. So that means it's nominal data. Okay, now part C, what percentage were female? So we just go back to our frequency table. There's nothing difficult about this, and it's this value here. So 45.4% were female. Okay, so part D asks to interpret and write a summary describing the frequency table. So this might be something that you put in a science report just to give a brief summary of what the report findings are. Now you don't have to put every little detail in, but the most important things. So this is an example of what I might write for this particular table. A region was monitored for koalas and a small sample of 22 koalas were recorded in the area. Of this, it was seen that the percentage of male to female was reasonably even, with percentage male koalas at 54.6%, just above that of female koalas. So the important stuff here is letting people know what you're doing, the sample size, the fact that the results are reasonably even is important. And male koalas, you've given that value, and then you've just said that it's just above female koalas. You don't need to state the exact values because you've said they're reasonably even, and there's nothing that really stands out there other than that. In a class of 30 students, they had a short maths quiz and scores were recorded out of 10 as follows. A. Is the variable maths score nominal or ordinal? B. Construct a frequency table and include percentage frequency. C. What percentage of students passed, i.e. 5 or more out of 10 is a pass? And D. Interpret and write a summary describing the frequency table. Okay, part A. Is the variable maths score nominal or ordinal? Because the maths score is numerical and it can be ordered lowest to highest or highest to lowest, then it's considered ordinal. Okay, so part B says construct a frequency table and include percentage frequency. So this time we've got quite a range of numbers. Let's just have a quick look at the numbers, what the minimum is. So we've got 3 is the minimum maths score and 10 is the highest because there's only 10 questions. Okay, firstly we set up our frequency table. Now we've got the variable that we're talking about in the first column, maths score, frequency, so the number of people scoring 3 or the number of people scoring 4, etc. And then the percentage for that particular score. What percentage of all the students scored 5, for instance? Now one thing you think about when you're setting up your table is how tall or short you need it. The last example was just male-female. There were just two rows. This time, what's our minimum? We've got 3 is our minimum and 10 is our max. So we're going to have a total of 8 rows plus the final total row. So let's go ahead and write out the numbers. We start at 3, 4, 5, 6, 7, 8, 9 and 10. And then we've got our total at the bottom. So now we go through and work out for each of these scores how many there are. So going through the rows of numbers, there's 3 there. There's only 1 3. So we go ahead and put a 1 in that column. Okay, let's look at 4s. So there is 1 4, 2 4s. So we put a 2 there next to the 4. In the 5s, we've got 1, 2, 3 5s. So go ahead and put a 3 there. 6s, 1, 2, 3, 4, 5, 6, 7. So 7 goes in there. How many people got a score of 7? 1, 2, 3, 4, 5, 6, 7. 7 goes in there as well. How many got a score of 8? 1, 2, 3, 4. And 9. We've got 1, 2. And finally 10. 1, 2, 3, 4 10s. Okay, we go ahead now and we add up the total in this column and we get a value of 30. So that should be the total number of students and the total number of scores. And now we work out the percentage frequencies in this column. Let's look at maths score 3. There's 1 person got a score of 3, so the percentage is 1 out of 30 times 100 to turn it into a percentage, and that gives you a value of 3.3 to 1 decimal place. Now let's look at the maths score of 4. 2 people got that score, so 2 out of 30, and then we turn it into a percentage by multiplying by 100. and that gives 6.7. Now looking at maths score 5, 3 people. So 3 people out of 30 times 100, and that gives 10.0. Okay, now maths score 6, 7 people, 7 out of 30 times 100 to turn it into a percentage gives 23.3. And if you have a look at maths score 7, 7 people got that as well, so that's exactly the same calculation, same answer. Maths score 8, 4 people got it, so 4 out of 30 times 100, and that is 13.3. Then for the maths score of 9, only 2 people got it, but if you look back up here, we've already done the calculation for 2 out of 30, which is 6.7. And finally, maths score of 10, 4 people. If you look here again, we've already done the calculation for 4 out of 30, which is 13.3. So finally, the last thing we do is add up the percentages and put the total down here. So if you add them all up on the calculator now, after you've rounded it all off, you're going to get 99.9. Now that's close enough to 100 that you can recognise that it's a rounding off error, so we just put 100. If you get a value like 97, then something's wrong. You need to go back and check for an error. If you get 100.1, it's likely to be a round off error. Okay, moving on to part C. What percentage of students passed? So a pass mark is 5 or more. So let's cut this off here, and we're looking for the summation of these values. If they asked for what number of students passed, you'd be summing these values, but they've asked for percentage. So the summation of those values gives 89.9% passed. So that's actually really good statistics for the maths teacher. The maths teacher in that class would be very happy. All the kids have done reasonably well. And finally, D, interpret and write a summary describing the frequency table. Okay, so if I was going to be reporting or making a summary in a science report for this particular frequency table, I would say something like a class of 30 maths students were tested, giving an 89.9% pass rate with 33.3% scoring 8 out of 10 and above. Now I've added that because 8 out of 10 is a pretty high mark, so I've made a cut off here. To get that value of 33%, I've just added these 3 values here. So that just gives you an example of, hey, everyone's passed. Probably most people have scored around these values. But we've got a pretty high percentage of people who actually got a really high mark. Moving on to the last one. A shopkeeper monitored which drinks were the most popular throughout a week of sales. A. Fill in the missing items in the table. B. Is the variable drinks sold nominal or ordinal? C. How many milk drinks were purchased? D. What percentage of drinks sold were Coke? E. How many drinks were purchased during the week? F. Draw a column chart for percent sold. And G. Interpret and write a summary describing the frequency table. Now, sorry I've given you so many questions here, but I just want to cover a few different things they might ask. Okay, so A is filling in the missing items. So we've already got our total here, and we've got our individual numbers of the items that were sold. So let's look at milk that we need to fill in. So we're looking at, for the percentage, it's 126 milks of all the 802 drinks times 100. That's the calculation that you're doing. So performing that on the calculator, you'll get 15.7. Now looking at Gatorade, so 142 Gatorades were sold out of a total of 802 drinks, turning it into a percentage by multiplying by 100. So that gives you 17.7%. And finally, you add everything up in this column to find the total. You'll get on the calculator, if you're adding up the rounded off values, you'll get 99.9. It's actually 100. But don't just assume it's 100. Make sure you do the calculation. As I said earlier, if you get something like 99.9, you know you're right and it's just a round off error. But if you get something like 96 point something or 97, there could be a problem with one of your calculations. Part B, is the variable drink sold nominal or ordinal? So these are your items in the variable: water, milk, Coke, Gatorade, Diet Coke, energy drinks. So these items can be categorized because water is not the same thing as milk, but they can't really be put in any numerical order, one being better than the other. It's a nominal variable. Okay, part C, how many milk drinks were purchased? So we go ahead and we look at milk. Now they haven't said what frequency, they've said how many. So we look at the number column. 126 milks were sold. Okay, part D, what percentage of drinks sold were Coke? So we go ahead and we look at Coke in the table. And this time they've asked for the percentage, so 25.9% of drinks sold were Coke. Okay, so part E, how many drinks were purchased during the week? So that's easy, that's just this value here. So 802 drinks were sold or purchased. Part F, draw a column chart for percentage sold. So we need to set up the axes as so. So on the horizontal axis we have our drinks sold, our variable that we're talking about, and then we break it up into however many segments. So 1, 2, 3, 4, 5, 6 segments for the 6 different variable options. Then on the vertical axis we have the frequency. Now this can either be the number or the percent frequency. They've asked in this question, they've asked for the percent sold. So therefore we want to graph this one. The trick with this is working out how to divide this axis up. And what we use is our minimum and maximums. So if we have a look at the frequency table, what's the largest value? We've got 25.9 here as the maximum, and the smallest is 12.2. We could start at 10. However, it's not unreasonable with such a small scale to go from 0 to 30. And then to make it really easy, because they're decimals, we can break these segments up into 5. So each of these little segments is worth 1. Okay, firstly let's look at water. So the value is 12.2. So for water, we want to find the point 12.2. So we've got 10, 11, 12. 12.2 is going to be roughly there. So we go ahead and draw our column for that variable. Now looking at milk, we've got 15.7. So 15 is here. So this is 16. So 15.7 is about there. So we go ahead and draw our column for that variable, for the variable of milk. Now looking at Coke, we've got 25.9. So 25 is here, 26 is there, just under 26. Now for Gatorade, 17.7. So 15, 16, 17, and this is 18, so we're just a little bit below 18. So go ahead and draw your column in for that value. Moving on to Diet Coke, so 16.1, 15, 16, so it's just above 16. Go ahead and draw that column in. And finally, energy drinks is 12.3. So 10, 11, 12, 12.3, about there. So that's the column chart finalised. So finally, interpret and write a summary describing the frequency table. So in a science report, or when I'm summarising the findings of my data, I might say something like, while monitoring the weekly drink sales, out of 802 drinks sold, it was found that the most popular drink was Coke, with 208 Cokes sold and 25.9% of all sales. The next most popular was Gatorade with 17.7% of sales, and water had the lowest percentage of sales at 12.2% of all drinks sold.